Okay, so you should have watched a video on solving parametric equations algebraically. My goal today is, as soon as you start this warm-up problem, which this is out of your, this is the last sheet in your note packet. There's a blank space up at the top where you can do this warm-up problem. That's why I left you a blank space up at the top. And then we got 2 examples to go after that one. Tomorrow, we'll do kind of a station rotation type of review, extra practice type thing. Friday, I think Schmeldog is got a short, quick solve review for you for Fridays as extras, because your test is a week from yesterday on this stuff. Okay? With me? All right. So with that being said, here is your warm-up. A Ferris wheel has a diameter of 80 feet, a period of 16 seconds, and the bottom of the Ferris wheel is 6 feet off the ground. Assume that the Ferris wheel is traveling in a clockwise direction and the passengers load at the bottom. Okay? Go for it. All right, talk to me. We need 2 equations. I need an x of t, and I need a y of t. They will be similar, but with a little bit of tweaks in betwixt them. How are they both going to start? 40. 40, because 40 is my radius. X is going to be sine or cosine? Cosine. Y is going to be sine. Okay. Then I need to have a b value. How do I figure out my b value? B is equal to 2 pi divided by the period, correct? What's the period here? 2 pi divided by 16 is pi over 8. Then I need to have a t. Where are we loading? Loading at the bottom. Okay. Here's the internal struggle that I have. Yes, I agree with you, because that's what it should be. But for some reason, it's positive 3 pi over 2. Yeah. So let's go minus here, pi over 2. Just because it's less. Plus 3 pi over 2 is the same as minus 3 pi over 2. Because it's loading at the bottom. It says right here, assume that the clockwise and passengers load at the bottom. It's different. Foxy, look at me. It's different. Don't look there.
Why is it?
I don't know. For some reason, it all of a sudden, like, it's doing it this way. And, like, I had to go back and figure it out, and I'm like, okay, I guess I told them wrong the first time.
Okay, so
Yeah.
if you start at the bottom,
If you start at the bottom, it's negative pi
but
over
if you
2.
start at the top,
Positive pi over 2.
so then it's the opposite from 3 pi over 2?
Yep.
Oh,
Yep.
okay.
Yep.
That's
Yep. Okay. Anything else that we need to add? What's negative because we're going counterclockwise? Nope. The negative pi over 8 has to be negative because we're going counterclockwise. Yep. This has got to be negative because we're going counterclockwise. Or we're going clockwise. We're going clockwise. Unit circle is counterclockwise. We're going clockwise, so that's why it's negative. Okay? Anything else that we need to add? Where? X or Y? Agree with those? All right, let's graph. What did I say? 40 cosine of pi, oops, negative, over 8 t minus pi over 2. Agree with that one? That's what it should be? Yep. Yep. Then, what's up? Yep. How long it takes to go all the way around? Because the period is equal to 2 pi over b. So b is equal to 2 pi divided by the period. The period is 16. How long it takes to get all the way around back to one spot. Now, let me see if I can do this. Anything else that we need to change on here? The t-value needs to go to what? At least 7, something bigger than 16? What's up, Trent?
You said that the period is 16, right?
Period is 16.
Then B would be 30. Oh, wait, no.
Divided by. Yep. B is equal to 2 pi divided by the period. Okay? Can't see it. Got to figure out where it is. So let's menuize, window zoom. Let's go into our window. Left and right, how far do we need to go? Left and right, we got to go at least 40, so let's go in 50s. Up and down. 0 is the ground. How far up do we for sure need to get to? 86 is the maximum height, right? So let's go to 100. Not a circle. That's just that's the screen. Yep. Okay. All right. Where is it? Okay. Question number 1 says, or the second question says, what is your position 2.5 minutes into the ride? Now let's do some maths here. 2.5 minutes is how many seconds? It's 150 seconds. How many laps around the Ferris wheel will you go in 150 seconds? Okay, what do we get? 9.375, right? So that means we're going 9 laps for sure. Yes? 9 times 16 is 144? Right? Okay. So how many more seconds do we go on that 10th lap? 6 seconds. So 2.5 minutes is also a t-value of 6 seconds. Would you agree?
Could you not just like change the t value to like
100%. You could change the t-value to 100% and trace all the way up to 150, or type in 150 and do that. Yes, but I can't do that if we left it at 17. Because it wouldn't calculate it because it doesn't know what it is.
you could just change it?
Correct. Yep, 100%. Yep. Okay. So what we're saying here is we need to trace, menu, trace, graph trace. There's us loading at the bottom. We need to go out to t equals 6. There we are at t equals 6. Or if we would, oops, not menu, escape, tab, we would have to change this 17 to something bigger than 150, and then we would be at the same spot at 150. So according to this, we are 28.3 feet left of center. And we are 74.3 feet high off the ground. Okay. Final question for the warm-up is, how far have we traveled after traveling on said Ferris wheel for 4 minutes? How many seconds is 4 minutes? 240, because I could multiply by 60 seconds over 1 minute, correct? How many seconds does it take to go all the way around? 16. So it takes me 16 seconds to make 1 revolution. How far in distance is 1 revolution? Yes, ma'am, it is 2 pi times radius. What do you got? I got it in exact already. You give it to me. 3 7. So you traveled almost 3,800 feet just in a circle. Okay. On your note sheet, then, we have these questions here. Ferris wheel with a radius of 40 feet rotates counterclockwise at a rate of 1 revolution every 15 seconds. Bottom of the Ferris wheel is 12 feet off of the ground. I would like you and people next to you to work on this one, and then we'll work on one more after that.
This, you can change this to like 1, it's 16 or 17, it has to be above 15, right? So it's 3 and how do I find that? It doesn't, I don't do that.
Spelling change this one too.
I
I rounded different. I got 0.55.
Yeah.
So I guess, yeah.
I don't know why spelling changed it off of 0.6, but
For what?
the last one.
Well, no, if you're rounding to just to the tens place, it is just 0.5.
0.5. Okay.
But then if you're, I went to the.
But if you round to the hundredths, then it's
then it's
0.55.
Because it ends up being 0.548.
Gotcha. Mm-hmm. That would be within my zone of I'm okay with. Yeah. 0.5 or 0.6. 0.5 or 0.6 is different than 0.85.
What?
0.1 of a foot is different than 0.8 of a foot.
Depends on how big of a thing you're talking about. though.
Margin of error.
Yep.
Good on that one.
Yeah.
This one on all.
Yeah.
Questions, comments, concerns? Need some helps.
I'm only on me, so. I couldn't tell you how I'm doing actually.
Well, it's all this is all calculated work. You know. Yeah. Good for the next one? Hammer and Hank. I know. What's up? Oh, you raised your hand. Oh, you were shushing me. Or you were shushing her.
No, she was shushing you.
I don't know why she was shushing me. I'm going to the next problem.
You're going a little fast.
It's all written in front of you.
Don't we have one? This is the last one.
This is the last problem today. So stop yelling at me for going fast, because I want to take a nap. Okay? Find me how far the ball travels.
Actually,
Here we go.
perfect.
Let's talk X. X of T for Hammer and Hank's home run ball. 160 cosine of 22 degrees times T. Okay, let's talk Y of T. Negative 16 T squared. Oops, I was about to put cosine myself. And plus 3.5. Now, we want to know what? How far away the ball landed, right? So how far total horizontal distance, right? What do I need to find in order to do that?
T.
I need to find T. How long it's in the air, right? Okay, how am I going to find t? How long it's in the air? One option is, what you've been doing, you can trace, right? We can graph this parametric function. We can drop our t-step down even like smaller and smaller and smaller until we get closer and closer and closer to it landing, right? Okay, that's one way of doing it. Don't like it, but that's one way of doing it. What's another way of doing it? Solve what? I'm going to use the y function here, and I'm going to set it equal to 0. And I can go on my calculator. I could use the quadratic function by all means, but I'm going to go on my calculator, and I'm just going to type in negative 16x squared. Oops, forgot the x. X squared plus 160 times the sine of 22 degrees times x, almost said t there, plus 3.5. And I'm going to hit enter, and that's going to give me a parabola that I can then now analyze for some zeros. So I get 1 0 there. Do I like that 0? No, because that's back in time. Can't do that. So I'm going to analyze for the other 0, and I get that one. So that's telling me that I have 3.80358 seconds that that ball is in the air. So what am I going to do with that 3.80358 time? Nope. Well, I could type it into trace, yes. Or I can just put it in right there for t. And so my x of t would be 160 times the cosine of 22 degrees times 3.80358. 3.80358. And I get 564.259 feet. Wow, because you're in radians.
Oh my gosh, why is my computer so low?
So what you can do, hey, easy one. Go back and just add the degree symbol. And it overrides the radians.
Oh. Why does my calculator do this? I feel like my calculator is kind of. That also doesn't get. Wait, how do you add the degree symbol?
It's under pi.